Bless you.
Bless you. For having good manners, I'm going to have to pass on that one. I do appreciate that there. Okay, so. Yes, okay. There were a couple more easy questions. Oh well, the recording's starting anyway. That's fine. You probably don't remember this, but it would be useful to know if we need to talk about timelines and such. Now, I guess you're not blind, and I guess this is not your first time class. And I know you already passed first semester with me. We've already been there, done that. So we made it this far. Clearly, we can turn our papers in or do something. So I get the review so far has been kind of pointless. But you and I both know there's a reason I'm going over these things. When is my day due? What? March. What day?
6th. 5th. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13.
You had such a good strategy. I'm just going to say all the dates. I'm just going to count them up.
So I got to book that?
Okay, if you said March, be honest. If you said March, you can have 1 point. It's March 9th.
Hey, I said 9, so you're going to give that away.
Okay, so let's talk about this. As of today, I'm 31 weeks, and most people are pregnant 40 weeks, so I've got 9 weeks left. Let's think this through. 9 weeks is starting as of today. How many weeks are in 9 weeks?
You're going to be gone this whole...
So I'm going to be gone at the very end of the third 9 weeks, more than likely. Now, my kid might decide to stay adult. I cannot control what I cannot control. I can only warn you about the things that I assume will happen. So, I assume that I will not be here at the end of the third 9 weeks. So if you're one of those people, I've got about 4 of you, maybe 5. If you're one of those people who tends to try to make it on up, on here at the end, it's not going to work. Now, I know I always say that, but this time I literally cannot help you. I bailed you out first 9 weeks, bailed you out second, and I'll come back and say today 4th 9 weeks. But third 9 weeks, I cannot help you. And if you mess up third 9 weeks bad enough, I'm awesome, but I'm not a miracle worker. So I cannot necessarily fix all that you messed up third 9 weeks during 4th 9 weeks. So let's talk about things. So let's pretend that this is a worksheet. It's not. We'll pretend it is. Let's say that was me, Xavier. Maybe Caitlin. Caitlin forgot. She didn't turn this in. She did this worksheet. She never turned it in. She turns it in at the end of the third 9 weeks. First of all, she did put her name on it. She did put it in the right drawer. She was headed in the right direction. First of all, the substitute's not going to know what that is. Second of all, the substitute's not going to know where I have my key. They're going to dig through my stuff to find the key. Then once they find the key, how are they going to know how many points it's out of? And then if they can figure that out, how are they going to know which assignment I titled it right now and how many points take off because how late it is? You can see how suddenly Caitlin's really late stuff. Because if you think I'm taking a satchel of papers with me to the hospital, not happening. So you've got to not let it happen this night. You've got to stay on it like white on rice. Because I cannot save you. And the substitute won't know what this is. Yes, dear.
How many weeks are you going to be out?
6.
Did you already say that?
No.
Okay, well,
that is my plan.
We're going to have a sub, like line sub.
That's
not a long time.
Is it going to be just one constant
We
sub,
bring
or
the
are they
baby.
going to
There's
like...
no back.
Okay, that's what I'm
There's
saying.
only points for the baby.
I have a clue. Is he going to know anything about math, or do you not? Okay, you already know the sub?
No, but I know what we've discussed, and they will know something. Yeah, no. I don't know who it is, but I know they will know something about math. They have to because of the stats.
Do we have loyalty class?
Okay, so what now?
We have loyalty class.
Okay, so
I believe in you, though.
So anyway, just a reminder, like things are happening and they are out of my control. But you know what we can control? Making sure we stay on top of it for now. We can. So we cannot get off our game because seriously, not going to be here to bail you out. So we've got to stay on it. So we're going to try to do a good job of staying on it. There was something else that I forgot. Okay, let's go ahead and get started. Oh, here's what it is. So we're starting a math workshop because that's what we tend to do at the beginning of class every day when I'm not rambling. This one says factor. We've done so many factor ones. Here we are again. What category does the math workshop test go in? It goes in the 60. But I'm not going to give you the point because they're on my nerves. I just have a point and you want to talk to I can't get it. Okay, so math workshop test, 60% category, still happening. Okay, so let's go ahead and do 1, 2, and 3. There is a slight typo in number 1. It's supposed to be both A's. God forbid we use variables other than X. We're starting off by reviewing some factoring ones. Notice the first 7 are all factoring. So if you tried to block factoring out over Christmas break, you need to bring it back to your brain. We can't factor this one yet. We need to do something else first. We do, before we get the point. We're going to have to add 48 to both sides. From here, it's an easy factor. Why is it an easy factor? Yes, but the reason that happens is because the leading coefficient is 1. So because the leading coefficient is 1, it's an easy factor. So I need two numbers that multiply to 48 and then add to 14. 6 and 8, you get another point, ma'am. So 6 plus 8 is 14. 6 times 8 is 48. So it's A plus 6, A plus 8. Yay. And again, this was all easy because that leading coefficient was 1. We're not done because of that equal 0 sign. We actually need two answers. Yes, and you can have a point, ma'am. So I set A plus 6 equal to 0. I get A equals negative 6. I set A plus 8 equals 0. I get A equals negative 8. I have two answers. And the reason I have two answers is because we're dealing with quadratics, meaning the exponent is a 2. If the exponent was a 3, we might end up getting 3 answers. The highest exponent tells you how many answers there could be. Okay, I'm going to skip number 2. Why am I going to skip number 2 for now? Because the leading coefficient of 2. 2 gets the point. I'm going to go to 3. But 3 has a leading coefficient of 7. There are only two things, so I can't do normal factoring. What can I do? And if you know what I can do, what is it? Yes, and what is it? Yes, there is a GCF, but what is it? Okay, so if I factor out an x, I'm left with 7x minus 4, and that equals 0. So I have two answers. One is x equals 0. What is my other answer? So what number? X equals what number? Yes, ma'am, you get your point. Okay. So we've handled 1 and 3. We've got to be brave and go back to 2. It has a leading coefficient of 2. What method do I like to use? I like to use guess and check to get a point. The other method that we discussed in the past was slide and then what words? Yeah, 2 get another point. Slide, divide, bottoms up. Okay, so I know that it's a 2a and an a because it's a 2a squared. I don't have any options. What's in pink is in stone. I knew it had to be that. What I'm questioning is what numbers to put here on the end. What are my options? It could be 5 and what? 5 and 2, or 2 and 5, or it could be 1 and 10, or 10 and 1. We're not sure. We're literally going to guess. So, I think positive 5, negative 2. That's what Brady wants to guess. Sounds good to me. When we check, what do we use? What's it called? Brady, you get your point. Okay, so let's FOIL it out. 2a squared minus 4a plus 5a minus 10. I combine my like terms, and lo and behold, I do have 2a squared plus a minus 10. So Brady has helped us guess correctly. However, Miss Compton's wasted all her room doing her check. She's still not found the 2 answers. So I need to set, Brady said 2a plus 5. So I need to set that equal to 0. Brady said a minus 2. I need to set that equal to 0. What are the 2 different answers? A point for each. That's 1 point. Yes, that's the other point. Okay, so we had some time off. We've come back and we're already hitting the ground with factoring, which sounds terrible, except we've done it 1,000 times, so hopefully it wasn't that bad. Now to talk about some new things. So I'm going to give you a brief refresher on what we were doing before we left for break. You do not have to write this down. We've actually already taken a test on this. We took a 5.1 test. So let me remind you, Chapter 3 was matrices and stuff. You loved it. Chapter 4 was quadratics. You eventually learned to love it. Chapter 5 is what we're in now. We've already tested on 5.1. You already showed me you know how to add, subtract, and multiply polynomials. In fact, here's a problem like one from your last test you took. Let's say 3a squared, you do not have to write this down, plus 1, plus 2a squared minus 3. If there was an addition sign in between, you would say 3 plus 2 is 5. Nope, you don't have to write it down. 1 minus 3 is negative 2. Most people were great at adding polynomials. Most people were also great at subtracting polynomials. Let's say I have the exact same 2, but instead of a plus sign, it's a minus sign in between. We would have said 3 minus 2 is 1. 1 minus a negative 3 is 1 plus 3, which is positive 4.
Teacher, students, can I have your attention, please? I have a quick announcement about the lunch schedule. Because on your students, on your new schedule, your lunch schedule is for the new campus, not this one. So please listen carefully. For the A lunch, it's 4th period teachers. If you have the following teachers for 4th period, you will go to A lunch for this campus. If you have Brittany Adams, Clinton Barthélemy,
That's me. What'd she say? A lunch. Oh, that's my normal one.
Mr. Burson,
I think just A because I go to
Yeah, some people can be.
Mr. Cole,
C.
Mr. Contact,
Like, please not be like Sue.
Okay. That was distracting enough. We can't get further distracted. Okay, so to summarize, I was going to work this example, I'm going to let it go. So, the multiplication, we would FOIL it out. You were good at foiling. In fact, most people did a great job on this test. Those who didn't do a great job, let me tell you what they did. They probably are zoned out now, Table 1. What they did is they ignored the sign. So on every problem, they decided it was a FOIL problem, even if it had a plus or a minus sign in between. So just recall this. It will come back. But so far, we've added, subtracted, and multiplied, and no one's ever asked me, hey, Miss Compton, why aren't we dividing?
I was just thinking about that when you said it.
Which is why today we're starting division. Now, division takes a little bit of time. That's why I gave you a cute little handout to try to help. Division is not hard, but it can be tedious, so you've got to make sure you're paying attention. Okay, so let's go to your packet. We're going to go to number 1. Number 1 and 2 are actually going to work out perfect, and we're not even going to have to divide. We do want to change one tiny thing on number 1, add a y to the numerator. It should be 18x squared y. Okay. Is there a GCF we can pull out of the numerator? We could pull out a 6, and then what else? X squared and a... Yes. And you're going to be really annoyed. So, 2 and 3 and 5 get a point. You're going to be really annoyed, though. I'm not going to pull out that GCF. Instead, I'm going to pull out a 3xy. No. I know. Now, Ms. Compton, why would you not pull out the 6x squared y? Well, because I'm smart. One, lose a point, you're on my nerves. Because I'm smart, I see the denominator has 3xy. I'm thinking, hey, maybe I can make stuff work out, so I end up canceling the numerator and the denominator. So literally, that's why I'm going to factor out a 3xy, if it all works out. So if I factor out a 3xy, I'm left with what? 2. Please, Drea, keep going. And then minus what? 6. Thank you. Okay. I notice, hey, I factored out a 3xy. There's a 3xy in the denominator. I can cancel those out. And so my final answer is the pink. So my answer is 2x to the third y squared plus 4x squared y minus 6x. And I didn't actually divide anything. I pulled out a GCF, and then it just so happened that the numerator and the denominator canceled out after that. Does that always happen? No. But kind of like how factoring can be so much easier if you notice a GCF, division can be so much easier if you notice there's a GCF. You can end up, you can end up making a problem take all day long when really it was going to be easy because there was a GCF. Okay, let's look at number 2. Number 2 doesn't even look like a division problem. There's no division symbol. Why do I know? And what am I going to do to that negative exponent? And you can have 2 points. Do you see that -1? So everybody who was raised to -1, the 4c squared d squared, has to be punished and put to the denominator. And look, lo and behold, we really did have a division problem. I could factor out of the top 8c squared d squared. I don't want to though. What do y'all want to factor out of the top? Yeah, and that makes perfect sense because again, I'm really just hoping to make I'm trying to make the numerator and denominator cancel out. That's my whole goal. Okay, so if I factor out a 4c squared d squared, what am I left with? D to the, So 16, 2 plus 2 is 4, 2 plus 3 is 5, she's right. And then what? Minus 6. And that's it, because the c squared d squared, we already factored that out. 4 times -6 is -24. Perfect. Those cancel out. And my final answer is seriously 4c squared d to the third minus 6. And we're done with that one. Now again, most of the problems we work do not work out this nicely. But man, it sure is nice. If we notice that there is a GCF, it does tend to make our lives easier. The way 1 and 2 really weren't that bad. However, since most problems aren't like that, we have to discuss a method, a division method that's actually going to work out for us. So we're going to use long division, which you've actually heard of before. So pull out your cute little handout that says polynomial long division. It has a typo on it. I fixed it. If you got one of the new copies like DJ, I fixed it. The 6 that was written there, cross it out and put it by the 7. Okay, this handout is yours. There are 3 problems on it. One is old school long division with just numbers. The other 2 are polynomial long division. Now, I'm not going to go over the other 2, but if you get stuck, or you don't understand what I said today, or you just like to have a reference, this is a really good sheet to look at, especially down at the bottom, because in the little bubble, she explains how she got it through. Okay, so I'm going to work out this problem, and I'm going to do it on my own paper so we can talk through the steps that you used in long division, because that's what we're going to use in polynomial long division. Okay, so 7 and 1, 2, 3, 4. If I wanted to divide 7 into 1, 2, 3, 4. Now, I know it's been a long time since you tried to do this, and I know you eventually just got to use your calculator. But when you used to draw the house, you would say 7 doesn't go into 1. 7 goes into 12 one time. 7 times 1 is 7. And then what would you do? You would subtract, and you would get 5. You'd bring down the 3. Yes, so 7 times 7, so you say that's 49. I get this exact ones on your paper. It's intentional. So you get a 4. You bring down the other 4. 6, you get 42. And you're left with 2. So, oh, that's the word I wanted to hear. You can have a point. So, because we didn't end up getting a 0 at the end, we have a remainder. What would we do with that remainder? We would. 3, get a point. We would put it as a fraction. So we would say 2 over the thing on the outside, so 2 over 7. And the same thing's going to happen today. If we have a remainder, we're going to do whatever our remainder is divided by the number on the outside of the house. Whoa. Okay. So this same process is what we're going to use today, but instead of it just being numbers, we're going to have variables and exponents, but life's still going to work. We're still going to subtract. We're still going to bring down. We're still going to have a remainder. The main steps are going to remain unchanged. So if you understand that, which you do, then today shouldn't be that big of a deal as long as you keep up with what you're doing. Okay, so let's look at number 3. Number 3, we want to divide x minus 5 into x squared plus 3x minus 40. Now we're going to say, you know, how many times does x go into x squared? It goes 1 time, because x times x is x squared. And everyone should be good with that. X times x is x squared. Great. And I'm going to make those 2 cancel out in just a second. Hold your horses. But what's different is I've also got to deal with that negative 5. So I did x times x and I got x squared. I also need to do negative 5 times x and get negative 5x. So I did x times x and I got x squared. I did negative 5 times x and got negative 5x. Are there any questions about the orange? So I did x times x and I got x squared. I also did negative 5 times x and got negative 5x. Because I knew x times x is x squared. My goal is to make that first thing cancel out, just like your goal was to try to make the 12 cancel out a second ago. And you said it went into 7 1 time. You were trying to make that 12 die at first, right? In the same way here, we want the x squared to die first. So we're picking numbers. The orange things we picked are all because we want that pink x squared to die. And it's going to. Now, normally you would tell me from here you subtract it. So we're still going to subtract. X squared minus x squared. Hey, the x squareds really did die. That's what we wanted to happen. So I've now got 3 minus a negative 5. And all of a sudden, Travis is stumbling on to what happens. So you say 3 minus negative 5. Isn't that really 3 plus 5? Which is really just 8. 3 minus a negative 5. So it's 3 plus 5, which is really just 8x. If you want to distribute that negative sign, you can. But what happens is a lot of people will make a sign error here because they'll forget about the fact that we were subtracting the whole thing. And they'll say 3 minus 5 is negative 2 instead of 3 minus a negative 5. Are there any questions about the blue? We are going to bring down the negative 40. And we are going to pick 8. So we're trying to kill off that 8x. X times what gives me 8x? Well, 8. So I do x times 8 and I get 8x. I still have to use negative 5 times 8, and I'll get negative 40. Are there any questions about the green? Okay, well, I'm still going to have to subtract that second line because I want the 8x to die. So I need it to be 8x minus 8x. So 8x minus 8x, the x's do die. But I have negative 40 minus a negative 40. So what do I end up with at the end? I end up with a 0. It's negative 40 minus negative 40. So it's negative 40 plus 40. It ends up being a 0. Okay, so do we have a remainder? No, because we end up at a 0. Does it always work out that way? No. Sadly, it doesn't. Now, for this one, because we have no remainder, it is easy to do a check. Do I make you do a check if there is no remainder? No, God, no. Okay, so we could check it. So we were dividing. Well, how do you check to make sure two things really did divide into something? You multiply them back together. So if you multiply x minus 5 times x plus 8, you end up with x squared plus 3x minus 40. Let's see. X squared plus 8x minus 5x minus 40. So x squared, combine those like terms, plus 3x minus 40. Hey, I did. I know I'm right. When I divide x minus 5 into that, I really do end up with x plus 8. Now, do you have to take yourself? Absolutely not. I just wanted to prove a point that really what we're saying is when I divided this into this, I ended up with that, which makes sense because when I multiplied those two together, I ended up with that. Okay, are there any major questions about number 3? I promise if you will help me work out number 4, I'm not going to make you do any more of these for homework. But the time is coming and there will be an assignment on it. It'll be a fun one, but an assignment on it nonetheless. And, of course, eventually there is a test, as always in life. Okay, so number 4, I'm going to put 2x plus 1 on the outside of my house. I'm going to draw my house. And then before I go crazy, I need to think things through. There is something, and darn it, number 4 had to make life complicated. It couldn't just be normal. There is something missing in that thing I highlighted in yellow. What exponent is missing? X to the what power? Look at it. The third. Where do you get the point? I see an x to the 4th. I see an x2, an x1. I don't see a 3. There's no 3. So I'm going to put the 8x to the 4th. But instead of immediately putting minus 4x squared, I'm going to put in a placeholder of 0x to the 3rd. Now, we will come back in a second and talk about why I put this guy in there. But trust me, we want him. Minus 4x squared plus x plus 4. Okay, so let me make that little note to myself. Put in 0 if exponent missing. Or put some sort of note to yourself about how we had the 3 missing and we're putting in a 0 placeholder. The reason we want the placeholder is the way we like things to line up just so. If we don't put in the placeholder, stuff's not going to line up. It's not. In fact, we're going to see on the first line why we would be sad. Okay, so I'm trying to divide 2x into 8x to the 4th. How many times does 2x go into 8x to the 4th? 4x to the 3rd. And is he right? 2 times 4 is 8. X times x to the 3rd is x to the 4th. He is correct. Okay, so 2 times 4, I get 8x to the 4th. Yeah, I agree. But I also have to do 1 times 4x to the 3rd. So I'll get plus 4x to the 3rd. Are there any questions about the pink? I did 2 times this and got that. I did 1 times this and got that. Okay, well, I want the 8x to the 4th to die, so I subtract the second line. I say 8 minus 8. Now those go away. Bye. But 0 minus 4x to the third, I end up with negative 4x to the third. And all of a sudden, I'm really glad I put in that 0 placeholder, because otherwise, wouldn't it be lined up underneath the negative 4x squared and we would be confused. I'm going to bring this guy down. Are there any questions about the orange? Okay, so I did 0 minus 4x, so I got negative 4x. Everyone's good to the orange. Okay, well, I'm going to bring that guy down just because I'm starting to get the hang of it. We need 2 people every time because we've got the 2x and the 1s. We need 2 down here every time. I'm getting the hang of it. Okay, so 2x goes into negative 4x to the third. What should I do now? How do I go from 2x to negative 4x to the third? Negative 2x squared. 2x times negative 2x squared, well, it's going to be negative 4x, and then the 1 plus the 2, that is to the third. She is correct. But what I did 2x times the green. I still got to do 1 times the green. It's only fair. So 1 times negative 2x squared, I get negative 2x squared. Are there any questions about the dark green line? Okay, well, just like with our others, we want to subtract that second line because our goal is for the 4x to the third to die. And that's the only way to make it work. So we'll have minus, so it's a minus a negative 4x to the third. So the bottom one's a positive, so a negative and a positive. Don't they cancel out? And then I have what? Yes. So I have, yes. Yes. So I have negative 4 minus a negative 2. So I've really got negative 4 plus 2, which is just negative 2x squared. Perfect. Are there any questions about the dark blue? And then Travis is already on it. Yes, bring down the next guy. The good news is Eric realizes the end is in sight. Because while we brought down the x, there's only one more person we could bring down, and that's the 4. So we're getting close to the end. There's only so many people you can bring down to save the day. Okay, so we're trying to think through. These two, if it was both 4s, yes. But because one's a 4 and one's a 2, no. Otherwise, yes. If they had the same number in front, yes. Okay, so I'm trying to go from 2x to negative 2x squared. What? I multiplied by x, but wasn't it a negative x? 2x times negative x is negative 2x squared, yep. 2x times negative x, negative 2x squared, yep. And then I still have to be fair. I have to do 1 times negative x and get negative x. Are there any questions about the pink? Now here is where Ms. Compton gets really excited and she's got to think things through. Again, every single time I put the second line in parentheses, I put the minus sign out front. Minus 2x squared minus the negative, yes, those do end up canceling out. But I was really excited and I thought it was going to be x minus x and I was going to get 0. Am I right? No. It ends up being x minus a negative x, so x plus x, which is 2x. Now, if Dahlia's like me, because she wanted it to happen, she made it happen, as long as she keeps rolling with the problem, she's going to get 95% of her points. I mean, maybe I take off a minus 1, not much. But if she just quits there, that's when I have a problem. Okay, I got to bring down the 4. Okay, so I'm trying to think through how to get 2x into 2x. Well, that's easy. It's just a 1. 2x plus 1. So 2x times 1 is 2x. 1 times 1 is 1. But every single time, I've been subtracting that second line. So I have 2x minus 2x. Those do cancel out. But I've got 4 minus 1, which is 3. Are there any questions about how we ended up with the 3? Okay, so we have a remainder, so we need to put the 3 in. Yes, Caitlin, get a point. So we need to put the 3 as a fraction. So it's going to be 3 over what we were dividing into our house, which is 2x plus 1. So that remainder, we still put over what was on the outside of the house. So literally our final answer, even though it's crappy, it's still our final answer, is 4x to the third minus 2x squared minus x plus 1 plus 3 divided by 2x plus 1. Now, why on God's green earth are we doing it if there's a remainder? Well, we have to understand the process. We have to, respect the process. We have to see if there's, but really it's stupid when there's a remainder because you can't multiply it back out and really figure it out. Okay, I swear we're going to do more of these to come. If you're still super stuck, look over that cute little handout I gave you. If I were you, I'd rewatch this. I swear I'm going to do it again tomorrow, and we're going to practice it on Monday. But we're starting off the new year with a hard topic. It's like going